Hey guys, if you own one of our Blaze burnishing tools, you see it here? You're going to want to hear what I got to say because this is going to help you take it from your toolbox to the work without no bullshit, all right? I'm going to start here. You know who we are. I put a lot of them in the street. Now guys have got them, they got to know how to use them the easiest way they know how, and that's what I'm trying to do. Let me start here with this here. I'm gonna start with the obvious questions. All right. How much? That's what everybody asks. $50. $50 FOB Freetown. That means freight on board. You come to my door, you give me $50, I'll put one of these in your hand. Not gonna happen, I know that. So it has to be shipped somewhere, and I'm talking anywhere within the 50 U.S. states. All right? Uh, well, I don't know. No, maybe the lower 48. I'm not sure about that. But the post office charges $10.20 for the lower 48. I wasn't thinking of Alaska, you know what I mean? But, anyways, you see this says this this burnishing tool is a game changer. If you handle this thing right, you use this on a regular basis. If you have to get deal with all the obnoxious math, it'll die in your toolbox. You'll be blowing dust off it. All right. See this statement? Ask the man who owns one. Packard car, Packard automobiles in the USA. It was called the American Rolls Royce. Fine car. They sold a shitload of them. Their advertising budget was nothing. The only thing they ever said was, ask the man who owns one. And believe me, they sold a whole lot of nice cars. All right? All right. That's it. Now let's go down here. In order for you to take this out of your box and use it quickly, you need a chart to look at. You're not gonna. Well, I'll show you the chart and then I'll show you some of the problems. See this? This chart is 303 and 304 stainless steel burnishing chart. Why we put two on one chart? Because in our testing, our real world testing, they both worked out the same. So we used one chart for them two different stainless steels. But let me show you something here. I'm going to show you how complicated this can get. Up to now, you see all them different types of materials: drill rods, stainless, different stainlesses, aluminum, steel, titanium, and even C360 brass. Right? There's 12 materials there. Suppose you had a 3/4 inch diameter drill rod, right? And then you went to a 3 inch diameter aluminum 6 inch. The settings are not going to be the same. You're going to drive yourself nuts trying to figure out how to go from the toolbox to the piece. You understand? We've done all that. We're the ones who are laughing at streetlights. You understand? What we did is we made a chart that goes from 3/4 inch diameter to 3 inches. All right? Right now we got 12 materials. Let me get it back down to the chart. See that chart over there? I'm gonna top left hand side. I'm gonna show you. You see what it says? Diameter. 10 different diameter sizes. 3/4, I'll go slowly down to 3 inches. You see it? Right? Each diameter range has different RPMs. Alright? On different settings. Alright? See what it says here? I'll put it to the left. Turning feed per revolution, burnishing feed per revolution. That's the feed rate, right? They're both the same. Let me go down to the bottom. Why are they always the same? Because we want a constant feed rate, which gives you smaller peaks and valleys, right? If the finish is good, the burnishing is good. That's why the 2000s. Let me go over here. Now we're going to get to the turning and burnishing RPMs. See, it says up top, turning RPMs and burnishing RPMs. That 1.55 is a mathematical thing. I'll show you in a minute. At the smallest diameter, the RPMs are the highest, right? 439. The burnishing is faster than the turning. It's 1.55 times the turning, right? Now you can see the turning at the smallest diameter is 439. The turning at the 3-inch diameter is 110. You can see the difference, right? Obvious. We call it constant surface speed. It's like the CNC. All right. The number of passes, I'll just show you. They're all the same, no matter what material. 2 passes. You go all the way down. Right? This is for burnishing. The first pass is from left to right. That means from the tailstock going towards the headstock. The second pass is from the headstock to the tailstock. All right? I'll show you that. I'll demonstrate that. See, it says wet or dry. We did them all wet. You see it? What we did is we put 2 drops of oil on the burnishing ball and a couple drops of oil on the material. All right? Now let's go here. DRO offset. In other words, you're gonna touch off, and you're gonna set your DRO 10 thousandths. They're all the same all the way down. If you don't have a DRO and you're using a dial indicator, it's half of that, 5 thousandths of an inch. You see it? Okay, now let's go here. The diameter difference from the turned surface to the burnished surface, minus 3/10 of a thousand. You can push all you want. That's it. You're going to get 3 thousandths, and it's going to be nice looking. Let me get back now. All right? Now let me show you some of the math involved. Look at here on the left, all the way down. See the red borders around all of these? Right? We're changing surface speed in inches per minute to surface speed in feet per minute, right? Right? And we're getting the RPMs in there. A lot of cumbersome math you don't want to screw around with. But let me blow this up, just to give you a for instance. See, here's a formula. Circumference equals pi d, blah, 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 blah. These are inches per minute. See it? Constant in it. And then we translated it to 86 surface feet per minute. That's the normal nomenclature. You don't want to know that. You want to know RPMs, and that's where we took it. All right? Let me get back. Just want to give you an idea. There's a lot of bullshit involved. You want to go from the toolbox to the work without all the math. You see this name, Doug Perfetti? He's laughing at street lights because he put a lot of this data together, right? real world data, not bullshit, right? All right. You see this? This is 316 stainless. We don't have it on the chart I showed you, but I want to show you there is a difference. That's why I put it up there. The turning was 165 RPM. The burnishing was faster, 330. That's what he did, and that's how it come out like you see it. I'll demonstrate in a minute. But just put a pin in this. Turning 165, burnishing 330, a 1-inch diameter. Let's go to the chart. See this 1-inch diameter? We went 330 to 510 on 304 stainless. Let me blow it up so you can see it. There it is. 330 to 510. He went 165 to 330. You can see. So, I mean, how would you know that? He knows it because he did it. What a pain in the ass. All right? All right, let me demonstrate this for you. All right? How do you know how much to push in? Let me blow this up and I'll show you. You see that red circle? Over here it says ball. This is the same size here. Let me show you how you're going to touch on. Oh, Jesus Christ. It's computer. Hang on. I'll get it. I wish I knew what I was doing. Hang on. God damn it. I can't believe this. I finally figured it out. I had a brain fart. Let me do this. Uh, you see this right here? All right. Here's what you do. That red ball, that red thing I'm moving around, that's the same size as the ball. What you do to set it, you come up and you dial it in. You put your finger on the ball bearing, not the ball, on the ball bearing, and you dial it in gently up against the turn surface. You just touch it, right? When you gently come up against the turn surface with your finger on the ball bearing, not the ball, when the ball bearing starts to turn, that's when you're going to make your setting. Let me show you. You're going to set your DRO on 0, right? Or your dial indicator on 0. You're not going to push it in. You're going to come off the workpiece and dial in the required amount. 10 on the DRO or 5 on the indicator. You see it here? All right. Now you're off the workpiece. You come over here and you're off the workpiece. You set your feed rate at 2,000s per revolution. You can go from right to left, from tailstock towards the headstock. You come up here. When you reach your destination, you change the feed on the carriage to go the opposite, from left to right. Then you come off, slowly like that, off the piece, and that's it. That's considered 2 passes. All right? All right? So that's what we're saying right here. Now let me do this. All right? So that's what you got. You can see how nice that looks. Right? And now all you got to know here is a couple of things. You got to know what the turning diameter, the turning RPM, and the burnishing. You got to know how much to dial in, and you got to know the feed rate. You know, you go right to left and left to right. That's the hot setup right there. That's what you got to know. All right. Now, if you guys, you know, if you understand what the hell I'm trying to tell you, tell me in the comment section. If you don't understand, also tell me that in the comment section. Give me your questions and I'll do it again. It's important that we get this right, because this is the beginning of a whole bunch of burnishing charts. So I need to do it right. I need your help. You understand? All right? Hang on. All right. I think that's all I got. Anyways, let's go down here. Like I said, comment. Let's not screw this up. If you own one, you got to help me out, because I'm trying to help you out. I'm trying to help us out. You understand? So, like they say in Tinseltown, that's a wrap.